So last time we talked about data frame, read a CSV file to R and manipulate the data using the package dplyr. So those are the functions we talked about last time: select, filter, mutate, group by, and summarize, arrange, and count. And also it's kind of follows the description of the each function. We also talk about pipes. The pipe operator looks like this: percentage greater than percentage, no space in between. And pipes, it sends the output of one function of from the left to the next. So we can combine several functions, create a workflow to finish more complex data wrangling operations. We will use pipes a lot in this session, and we will also use some of the dplyr functions we learned last time. Today, we will introduce two packages, tidyr and ggplot2. Tidyr is to reshape the data to different formats or different layouts. ggplot2 is to create visualizations. First, we are going to talk about tidy. What does tidy data mean? The concept comes from Hadley Wickham from his article, Tidy Data. If you're interested in the article, we already have the link in the guide, so you can find it here. This is his article. And basically, tidy data follows three principles. Each variable has its own column. Each observation has its own row, and each value has its own cell. We can see some examples here. This is kind of the schedule of classes. So you can see the columns is the Monday through Friday, and the rows is kind of like the time. But if we want to put this data into a table or a data set, we may arrange it this way. So each class has its own row, and each variable, ID, class, day, and time has its own column, and each value has its own cell. It looks like it follows the rules, the three principles of tidy data. But if we store them this way, it's not easy for us to use. It's not easy to read. In this schedule of classes, we expand day to make them columns. This is not tidy, but it fits our needs much better. We call this format or this layout wide, and this one long. In Excel, Excel has a function called pivot table. So we can use pivot table to convert the tidy or the long one to a wide one. So we can do it this way, and so we put the dates as columns and time as rows, and we can put class as the value. It's a content, but it's not exactly the same. Let's say, let me kind of turn off the grand total. So it looks kind of much similar then the schedule of classes. But we need to change this is kind of the count, and each cell has only one class. But in Excel, we use this function, pivot table, to convert the tidy or the long table to the wide format. In R, we're going to use commands to do that. So first, we will go back to our project, Sarfi project. For me, it's on my desktop, our workshops, and Sarfi, that's in that folder, I have the project, Sarfi R project. Please open this file. And it opens my RStudio. And you can check the working directory. It's exactly what we want. And this time we're going to create a new R script. And we save it to the Sarfi folder under scripts. And this time we name it as day 3 and data visualization with @_. So we can see it is here. And we put some file information. Title is reshaping and visualization. And you can put author name and also today's date. So first, we're going to talk about pivot wider. Pivot wider, which means we are going to convert the pivot table, convert the tidy data, the long format into the wide format. Before we can do that, we need to load the library tidyverse and Control Enter to run this function. And next, we need to read our data into interviews. We use Alt-, and then we use the function read_CSV. And we know our data is under data folder, and the file name is Sarfi clean CSV. And we know we have missing data displayed as null, so we convert them to NA. The function we're going to use to convert a long layout or long format into a wider format is pivot wider. So we can take a look. This is kind of look like our data. We have the variable or the column respondent wall type. It looks like this. And we have 4 different types of wall type. Some bricks and burnt bricks, cement, and mud daub. So this is kind of the long and tidy format. and we want to convert them to wide format. We will expand each value of this word type into columns. And we know for the row 189, the word type is some breaks. So the some breaks column, the value should be true, and all the other 3 columns, the value should be false. This kind of be the results as the wide format if this is the long format. For the function pivot wider, it basically has 3 arguments. The first one is the data or the data frame we want to convert, we want to reshape. And the second one is name from, which is the column or the variable whose value will become new column names. So for this, in this case, it should be the respondent word type, and it will convert to, change to the new 4 new columns. This is the second argument. The third argument is value from. The value from, that is the column or the variable whose value will fill the new column variables. It will fill this area. And actually, we don't really have this column in our data frame. So first thing, we need to add this column, add true values. And then when we convert, this column will be filled in this area. And it will, we will see some missing data. And we will replace this missing data with false later. Okay. So we will see how it works. Okay. So we will start with, first we're going to name this new data frame interviews wide. And we start with interviews, and then this is the Control-Shift-M for this pipe. Before we can use pivot wider, we need to add a new column. That's the one we call that word type logical. So first thing, we're going to add a new column. The function we're going to use is mutate. The column name is word type logical, and all the values are true. And we set it to the next function, that's pivot wider. So for pivot wider, we already talked about it has the argument names from. So that is from the respondent word type. And another one is values from. that's the data. That's the column or variable we're going to use to fill those new columns. That is our word type logical. We want to change those NAs into false. Pivot wider has another argument that's called values fill. And this time we are going to use false. Now we run this command using Control Enter. So we see a new object, a new data frame created. It has 131 objects, observations, and also the column number changed. It has 17 instead of 14. So we can take a look at these two data frame. So we see the original one. We can see the respondent word type is kind of before rooms and between after the year's life or leave. And that's 14 columns. And this white, between these two columns, we didn't see this one, this word type column. Instead, at the end, we see 4 columns. So that's kind of the 4 different types of word types. And so when we run this command, pivot wider, it drops the column we kind of expand, and then it generates the new columns. Do you have any questions so far? If not, we're going to talk about the converting the wider to longer format. Converting longer. So the function we are going to use is pivot longer. So this is the kind of the wider format or the wider layout we just created. And we want to change it back to the long format. The function pivot longer has 4 primary arguments. The first one the same, that's the data frame we want to reshape. And the second one is column. So the columns are the names of the columns we use to fill the new value variables. So, which means this values. Columns means this values. And the third one is names to. Names to is the column. We're going to kind of host this values. And values too is where the values goes. All those values in this yellow area will goes to this column, values too. So now let's convert. Okay, this one. And this time we are going to create a new data frame. Is called interviews long. And we will start from the interviews wide. And we use that function pivot longer. So the first one is columns. We can take a look at this wide. The 4 items, 4 columns is from Madal to cement. So they are consecutive 4 columns. So we can use the columns Madal to cement. And names to, instead of names from, we will put them into a new column called respondent war type. And then the values too will be war type logical. Okay. We then create a new data frame, interviews long. We noticed instead of 131, we got 524 observations and 15 variables. So we can double click to view. So you can see when I double click, it runs the function view this table, this data frame. So here we can see at the end, all the 4 columns we created for the interviews wide were dropped. Instead, it created 2 new columns. One is the respondent war type, and another one is the war type logical. We know this is unique. The instance ID is unique for each observation. And for the first 4 rows, we know they are the same observation. And we can see the 4 different types listed, and only one is true. The other 3 are false. So we don't really want those false lines in this long format. So we can drop all those rows when the war type logical equals false. Okay, so we can do this first. The function we use will be filter. We filter by this war type logical. Then you can see the interviews long, the observation, the rows, the number of rows is down to 131. And all the 4 rows are all filtered out. And we have the data for the war type, and we don't really need this war type logical. So we can remove this line. To remove this line, we can use the function select. we can use minus to exclude. Now the column is down to 14. Actually, the interviews long and interviews should be the same in content, but just the difference is this column is at the bottom, at the end. While the interviews, that's the original data, the word type is kind of in the middle. So do you have any questions? If not, we are going to use the pivot wider to clean our data. To clean our data interviews. Okay, so now we don't need the interviews long and wide. We will take a look at our kind of the source file. And in the column items owned, you may notice we have several values in each cell. So that the first respondent has 4 items. They own 4 items, and different respondents have different items. And for some people, they don't have anything. So that's NA. And we don't want to see one cell has too many, have more than 1 values. So we want to split this column and make those values expanded as columns. And the same for the month of lack of food. Kind of the same situation. Each cell has more than 1 values. The difference is we don't really see missing data. We do not see NA here. Instead, if they don't have any, these respondents, they don't really lack of food all through the year, we will see none. Okay, that's the kind of the difference between these 2 columns. We are going to expand the items owned, and also we are going to expand the month lack of food using the pivot wider. Last time when we expand okay, I don't need to see this one actually. Last time when we expand the word type, we can see each word type has its own row, but this time they are all in 1 row. So we need to split them into different rows. So to do that, we will use a function called separate rows. As we know, we have NA in the column items owned. We are going to use another function called replace NA to replace the NAs. Okay. So this time we're going to create a new data frame called interviews items owned. we start with the data frame interviews. First, we will separate the rows, separate the items into different rows. Separate rows, it basically has two arguments. The first one is the column we want to separate, and the second one is the separator. We know that the separator here is the semicolon. So now we can use the function. Items owned, that's the column we want to separate. And the separator, SEP, equals to semicolon. If we run this part, we see a new data frame created, but we got over 600 observations. The columns won't change. So we can take a look. So here, items owned, and we know the first person has 4 items. Now it's split into 4 rows. That's why the observations kind of increased a lot. But it kind of looks like the way how the war type looks before we do the conversion, before we kind of reshape it to the wider format. We also know it has the NA. We want to replace the NA. So we send it to another function called replace. Replace NA has we need to put the items owned, and this time we want to replace NA with unlisted, no listed items. We can run it now to see. We don't see any change of the size of this data frame, but we can take a look at the content. We don't see any NA so far. No listed items. So it's by listed items. We will values that will be false. So when we run this command, we can see the observation, but the column, the number of columns expanded to 31. So when we take a look at this data frame, we see the items owned is dropped here. It's not here anymore. And we see bicycle, television, they are all expanded as columns. We even see the no listed items here. Sometimes we may want to know how many items a respondent has. So we can do the calculation. We can calculate that with a function called row sums. And with row sums, we can select this is the data frame we created. And then we select the columns from bicycle to car. So we will get a vector. It says kind of have 131 elements. The first one is 4. We know the first respondent has four items. And we can also check, let's say, the second person. Let's say the third person. The third person has only 1 item. So we can see the third element is 1. And the second one is kind of a lot, and it's 8. Okay. And if we want to add this to the original data frame, we can do that with using the mutate function to add 1 column to this. We can add that. Interviews and items. And we add this. Kind of embed. But also, there's another way. Okay, we can run to see the results. Oh, okay. We need to assign this back to so we can see it's 31 variables. It adds a new column at the end. That's the column. But there's another way, kind of easier, we want to use pipe. So back, we run this again. So the column down to 31. So we know this, the number of items column does not really created. So we can send it to the function mutate. And then we create a new column named member items. And we use the function row sums. And the same, select. Here we use dot. And then we put bicycle to car here. So you can see we add a new column to this data frame. And also we name this column number of items. The dot here is the kind of outcome from the previous type, from this type. It was sent to mutate, but not this select. So we need to use dot to represent this kind of outcome. Then we will do the same to another column, that is the month lack of food. So they are quite similar, so we can just copy the code. And we, instead of items owned, we just name them month lack of food. And we still start from interviews, and we separate, instead of items owned, we use month lack of food. The separator is also the same, semicolon. And as we already know, month lack of food does not have any missing data. It doesn't have NAs, so we can remove this row. And we need to mutate items. We use the month lack food, logical. And then pivot name instead of, so we just replace them, lack of food. And easy one, I just copy this, put it here, logical, and filled with was the same. And number, instead of number of items, use number month lack of food. And inside of bicycle and through bicycle to cars, actually, I don't know. So we can run this part first, and we will see how this part looks like. Here we generate a new data frame. That's the month lack food. And when we take a look, and we can see it has 26 variables. All the months are listed here. The first one is January, and the last one is none. Even the one before none is not December, it's May. It's depending on the data, not the order, the real order. And so we know, now we know it's January through March. And when we run this, we add a new column at the end. So it's 27 now. So now we see here, we have a new column. We do all those cleaning to kind of prepare a new data set for the visualization part. So we want to, we kind of do them separately, but we want the data sets kind of to be, to fix both problems or to make changes to both columns. So we want to put those two steps together into one. So the data frame we're going to create is called interviews plotting. This is for the visualization part. So we call this plotting. And we can copy all the commands we used here. And then we send the results to all the operations for the month's lack of food. We copy only from separate from this row instead of from the very beginning. We add this pipe at the end of the process to the items owned. When we run this long command, we got a new data frame. It's called interviews plotting, and it has 131 observations and 45 variables. We need the lack of food, and we can take a look at this data frame. So it has the items bicycle through car. And then it has the number of items each respondent has. And then it has January through none and the number of months lack of food. So, any questions? Is that too confusing or too fast? Okay. So when we kind of create this intermediate data frame, interviews plotting, we may want to kind of export the data. And to export data, the function we're going to use is write_CSV instead of read_CSV. So it has two parameters. The first one is the data frame you want to export. So in our case, it's interviews plotting. And next is the file. We can look at our tab for files. And currently we have 3 folders, subfolders, data, documents, and scripts. data is kind of for the raw data. We don't want to put the intermediate data into the data folder. So we can create a new folder. We just call that data output. So we put the path in the quotes. So it's data output and slash or backslash. We want to name it interviews plotting.csv. We control enter to run this command, and then we can take a look. We have this file in this folder, data output. So here is kind of the takeaways for the first hour. We talk about tidy data, the three basic principles. Each variable must have its own column, each observation must have its own row, and each value must have its own cell. And also we talk about reshape the data, the long format or the long layout versus the wide layout. So we use two functions, pivot wider to convert long or tidy data into wide format. And we use the pivot longer to convert the wide layout into long layout. And we talk about export data using the write_CSV. So it's kind of right of the time. That's the 2:54. So we come back at 3 o'clock. I will set up a timer. Okay. Yeah. If you have any questions, you can ask now, or yeah, you can ask later after the break. Okay, it is 3 o'clock, so we will continue. So in these hours, we are going to talk about another package, ggplot2. It is a plotting package in tidyverse. It is an implementation of grammar of graphics in R. So that's where GG comes from. In the package ggplot2, all the graphics are built using a layered approach. Layers are built up one by one to create the final graphic or the final chart. Each chart built with ggplot2 must include 3 layers. At least these 3. They can have more, but at least 3. So we will take a look at these 3 must-have layers. The first one is data. That's the data we want to plot, we want to visualize. The second layer is aesthetic mapping. We call that AES. It describes how variables are mapped onto graphical attributes or visual attributes. Those include X, Y axis, color, fill, shape, and alpha. Alpha means transparency. The third layer, must-have layer, is geometric objects. We call it geom. So it's kind of indicate how value are rendered graphically, or we say what chart are you choosing. You may use the bar chart or scatter plot or line chart. So that will be geom bar, geom point, and geom line. Oh. Okay, so with these 3 elements, we can create a template for ggplot2. We start with the data, and then we send the data using pipe to the aesthetic mapping. We use the function ggplot. And then we add another layer, which is the geom, geometrical object. So we will see our example now. Before we see the example, we need to get the data ready. If you followed me, you should create this data frame. It's called interviews plotting. If you did not follow me last hour, I mean, and you can go to our guide and then copy this code and paste into your RStudio here, this area, and then you highlight them and you run this whole data command. You will get the same kind of the interviews plotting. Maybe there's some difference. This one, you have those 2 number columns at the end. Otherwise, there's no difference. So now we're going to use ggplot2 for data visualization. So first layer, that's the data. We know we are going to use interviews plotting. And then we use pipe to send it to ggplot, which, well, we will put the aesthetical mapping here. But we can run this part first. Here, the plot tab, we can see a gray background. Nothing is really plotted. The only thing we know is the data, and we want to plot it. We don't have any other aesthetical mapping, or we don't have the decided which type of charts we want to use. So we see only the gray background. And in the GG aesthetic mapping part, we can specify x-axis. We can use the number of household member. Number of household members, and then for Y we will use number of items. We can take a look how the plot looks like now. So now still gray backgrounds, but we have the x-axis and y-axis. It's also already labeled as we specified here. Now we add another layer. We use the plus sign. As we already have two variables, we can try the scatter plot, which is geom point. Oh, geom point, sorry, not point. Okay. So now we see the points displayed on the scatter plot. So we want to take a look at this command line. First, about pipe and plus. I don't know if you use Python or some other languages. And in Python, indent, it means something. That's part of the grammar, that's part of the syntax. But in R, index is just for us easy to read, yes. And you don't have to put them in separate rows. So you can put them all together and you run this command, it will display the same thing. So we can clear this, okay. And then we run the command, it displays the results the same. But to kind of make it easy to read, we just put them in different, separate in rows. And ggplot, this function where we specify the aesthetic mapping, and this part is that can be seen by all the layers later, and that's a universal part. That's the universal plot setting. And we can also specify the aesthetic mapping here in each geometric object. But if you put something here, that will be locally to this geom function only. So this ggplot2 aesthetic is global, and this is local. And another thing to mention is this plus sign, which adds more layers on the top. And this plus sign must be placed at the end of the line containing the previous layer. You could not put it at the beginning of a layer, let's say. You will see an error message here. But if we do it this way, it works. Okay. As we know, ggplot2 builds up the layers by layers until the final graphic. So building the plots using ggplot2 is typically an iterative process. So we can start with something very simple, just like this one. And then if we want to add more elements or we want to make some changes, we can start from here. So for this plot, we know we have 131 points. But this plot does not look like it has so many points. And also we may notice these points, all the points are seems at the intersection of the whole numbers. So we can make a guess. Some points are on the top of others. So it's kind of overplotting. So usually there are two ways to solve the overplotting issue. The one is change the transparency. So we can see how we can do it by improve this plot by changing the transparency. So as we will start from this command. So I will just Control-C to copy this command and paste it here. So I will make modifications from here. So to add transparency, the settings is alpha. Alpha is kind of from 0 to 1, and it's kind of the 0.5 basically means that's 50% transparency comparing to the regular points. So run this. So it kind of changed a little bit. You can see some points are looking lighter and others looking darker, but it doesn't really helpful. So we can try another way. Another way is jitter the location of the points. So we kind of change the location of the trying points, move it a little bit away from the original location so they can display all those points. So the same, I will copy. Oh, I think I already have it copied. Yeah. And this time, instead of geom point, we are going to use geom tidyr. So we see more points now, and we see they are not all at the intersection of the whole numbers. So they kind of move themselves a little bit but not too far away from the original point. We can also combine these two functions, two methods together. And this time we use tidyr. And we add the 0.5. And also we can add some settings for jitter. So we can add width to 0.2 and also height 0.2. Height and width, they can be from 0 to 1, I think, and by default it's 0.5, 0.4. So this kind of means how far away those points can be around the original location. So we run it and we see the change. It's kind of change the transparency, and we can see there's some points gathered here. And also we can add color. We can set color equals to whatever color we want. So it changes the color of points, but it changes the color of all the points. So it may not be very useful. Sometimes we may want to color code those points by a categorical variable. Let's say village. We know we have 3 different villages. So if we want to kind of color them differently, we can also but instead of using color, we need to use a variable, village. Oh, yeah. So now they are colored differently. We can also add other layers. Let's say we want to add trend lines. We can copy this one, the last command we run, and then we add a new layer. We put the plus sign at the end of this current layer. We want to add another geom smooth. That's the trend lines. And the trend line we want to use is the, so we use the method LM, which is the linear mode. So we add this trend line. This is the trend line for all those points, not by village. We can see that kind of the smaller the household, the less the items they own. This is kind of the trends for all the villages. But if we specifically want to see the trend lines for each village, we can do that too. copy them and paste it. We can add the AES equals to so we see the different different in color. They color code the trend lines. This aesthetic settings is only logical, is only locally for this geom smooth, and this one is only for geom jitter. But this X and Y axis settings is universal for both two layers. Besides these two methods to kind of solve the overplotting issues, there's another way to do that. We can use the geom count. So this time we type from the very beginning, interviewers. And add a plus sign, use so we will see the different size, the location or the points, the location has more points. Its display is a larger point. We change the size. Excuse me. Do you have any questions so far? Next, we're going to talk about box plot. So box plot, we really use box plots to visualize the distribution of continuous variables. So for our data, we can use that for the distribution of rooms. How many rooms, or the number of kind of the size of the houses, how many rooms in each house. So we start with interviews. So this time we need only one variable, that's rooms. And we so we can see the box plot of the rooms. The box, it ranged from the 25th to 75th percentile. So it kind of contains half of the observations. the line, it should be in the middle, but for in this case, the line is kind of overlap with the bottom line, with the 25th percentile, and that's kind of the medium. So the difference between the 25th and the 75th percentile, that's known as IQR, that's the interquartile range. And this line, we call that whisker, that's the 1.5 IQR. And all those points, they are outliers. This is kind of how we read this box plot. If we want to see the distribution of rooms by wall type, we can just simply add a variable here. So now it's kind of, we see the room distribution by wall type. We see the distribution, but we don't see those points. Where are those 131 points? So we can add another line. Okay, I just copy them. I copy this command, and then this time we want to add points. We want to use the geom tidyr, and we will still use the settings equals to point, and we can put the color tomato color, and we set the width to 0.2 and height to 0.2. So when we run this command, we will see those points are added. But actually, this point is higher chances is this one. So as a kind of outlier, so we don't want to see the duplicates, and we can set the alpha equals to 0. So this disappears. So all the points are in the tomato color, and all the box is in the black. I just mentioned we add add layer by layer on the top of each other. So we know the points on the top of this box plot. If we change the order, we will see them differently. Oh. No. Oh, I set this as alpha. Okay. No, I don't think so. If I change this, yeah. So this way you can see the points is kind of behind the layer of box plot. So next we are going to talk about bar chart. Bar charts are useful for visualizing categorical data. So we have the word type is kind of categorical data. So we are going to use that to as an example. So we start with the data plotting, and then respondent type. Bar. So now we see the bar chart of the word type. We can also use the aesthetic fill kind of to color the bars by the portion of each village. Okay. So here, I just copy this one and paste it here. I will add aesthetic settings fill equals to village. So we will see this stack bar. We colored different, colored by village. And sometimes the stack bar is not easy for comparison. So we may want to see the bars side by side. We can add another settings position. So I copy this one, and then I add a new argument, position equals to dot. So we will see these bars side by side. The cement, we have only one house is built of cement. So it's very low here. Sometimes when we use bar charts, we want to show the proportion of each housing type in each village. So we want to show the proportion instead of the value. So we need to do some calculation. First, we will do some calculation to create a new data frame. So we call that percent word type. As we have only one cement house, so we want to filter that out. So we keep only 3 different word types. So the first thing we use filter. Exclamation equals, which means not equals to cement. We filtered the cement data out, and then we put we count So first, I'm going to show you the results, how this looks like. So I select only from here, not so you will see the results. It displays the count of houses by village and by ward type. So then we want to send it to, we group them by village. And then we calculate the percentage. We create a new column using mutate. The new column is called percent. And then we use n. This is the n column. And then divided by sum n. And then we make it a percentage. And after we group, this is a kind of a good habit. After we group the data by certain parameter and by certain variable, we want to release it. We want to ungroup it. So this will be our new data frame. Ward type, percentage ward type. And we want to plot this one. So first, this is our, and then we use ggplot2. We use x-axis village and y-axis percent, and we fill it with the respondent ward type. We're going to use geom bar. Usually geom bar use the count as the to show the height of each bar, but as we do this calculation, so we will use specify the stats as identity instead of count. So this is how the stack bar charts look like. If we want to show them side by side, we can just add position equals to Do you have any questions so far? And also, we see, let's say, we can add some titles for the plot, and we can change the labels too. So for that, we can talk about adding labels and titles. To add that, we can use the function labels. So we will do something. We don't need this one. And now we use labels. And we can add the title village proportion. We need to put this title in quotes. And also we can change the label for the field. So the field will be type of wall in home. And also we can change the label for x-axis and y-axis. It's currently all in lowercase. We can make them kind of title case. So you can see the title is added and the field title is changed, and then the two labels are changed. To display the bar charts of different villages, we can put them together side by side, and also we can put them into multiple charts. ggplot2 has a function called facet. So we can use that to create multiple plots. Still this one, we can copy them. And then we can add one layer for facet. This one is on the top of tilde. It's beside 1. So we display them in 3 plots. And also we can kind of use the theme function to remove the background. Currently the background is gray. If we want to remove the gray background, we can add the same black and white. And we don't want the gray line. We can remove the gray line, use themes too. You can use the theme function to customize the look and the feel. Let's say if you want to change the font size, I think you can use the one and you can set size equals to 16. Oh. So it kind of enlarged the font size. And so it displays all the 3 villages.
Okay, Jingjing, we're just at 3:45.
Okay, so that's the kind of finished all the content. And now we can take a look what we already covered the past hour, we talk about the three different layers, three must-have layers, and we can put them into a template. Like we start with data and we send the data to the ggplot2 function. We have the aesthetic mappings here, and also we add different layers geom function, geom objects. And we see the scatter plots, box plots, and bar charts. And we talk about facets. So we can create multiple plots using facets. And we talk a little bit about theme. We can customize the look and feel of the plots. That's all for today. And if you have any suggestions, you can put in the evaluation form.
And I dropped that evaluation form in the chat.
Okay, thank you. And if you have any other questions about your specific data, or you have questions about this class, and you can contact Cynthia or contact me. Here is our contact information. And we will put the recordings, we'll send the recordings, and also we will put the recordings on the guide.